Today we are going to look at the topic of absolute value and distance. This is a topic covered in the Pre-Calculus Mathematics module, Mat 1510, and the corresponding ESP module, XAT 1510. I have given the additions reference for your prescribed textbook. It's 6 and 7 on pages 8 and 9. Now, the one thing that we know about distance is that it's always positive or zero. In mathematics and in science, we refer to such quantities as scalar quantities. So these quantities only have magnitude, but the direction is not considered. So when I speak about a distance of, say, for example, 5 kilometers, it means that I'm only interested in the magnitude of 5 kilometers, irrespective of whether I traveled forwards to my destination or whether I traveled in reverse. So we are going to look at how we can represent the distance on a number line. For example, if we look at the distance between -2 and 5, how would we represent this on the number line? Right, so as you all know, our real number line, we've got integers, and what I'm interested in now is having a look at how to measure the distance between -2 and 5. So let's start at -2 and we end at 5. This means that the distance is represented by 1, 2, 3, 4, 5, 6, 7 units. Right? So that's going from -2 to 5. Now suppose we move in the opposite direction. In other words, we move from 5 and end at -2. Right, so now we're going 1, 2, 3, 4, 5, 6, 7. As you can see, irrespective of the direction in which we traveled, the answer for the distance between -2 and 5 will always be 7 units. Mathematically, we represent that distance of 7 units by the absolute value. The notation for absolute value is where the absolute value signs are those vertical signs that you see around the quantity as shown on the slide. So the vertical signs represent what we refer to as the absolute value sign. So this is a function called the absolute value function. Now let's have a look at how this absolute value function can represent the distance that I've just shown. Well, the absolute value function represents the distance from A to the origin each time on the number line. Okay? Which means that if I want to talk about the first example, the absolute value of 3, for example, what I'm actually looking at is the distance from the origin to 3. So I could go from 0 to 3, which gives me 3 units, or I could go from 3 to 0, which also gives me 3 units. So on the number line, the absolute value of 3 is therefore equal to 3. Number 2 shows us what we would get if we considered the distance from -3 to 0. Right? So on our number line, we now are looking at the distance from -3 to 0. So let us start at -3 and end at 0. From -3 to 0, we can count -3, -2, -1, 0. In other words, 3 units. If we go from 0 to -3, it is still 3 units. In other words, the absolute value of -3 is still equal to 3 units. So what have you noticed in examples 1 and 2? You've noticed that in both cases, the answer is always positive. All right? So in the notation in example 3, the absolute value of 3 minus pi, it means the distance between 3 and pi being rounded off to approximately 3.14 if you don't have a calculator. So that quantity in example 3 between the absolute value signs is already negative. In example 4, I've chosen any two values, A and B. So on the number line, you've got A and B. I haven't specified whether A is less than B or whether B is less than A. I simply want to represent on the number line what does the distance between A and B look like. So if we start at A and we end at B, then the distance will be represented as the difference between A and B. Okay? So in other words, we have the absolute value of A minus B. If I do the distance between B and A, then I get the absolute value of B minus A. And in both cases, irrespective of whether I went from A to B or whether I went from B to A, the distance between A and B is the same magnitude. All right, so let's have a look then at what the definition of the absolute value is. We have to do a split definition for the absolute value because, as you've seen from our previous examples, it depends on whether the quantity A is positive or negative between the absolute value signs. All right, so let's take the first case where A is greater than or equal to 0. So A is positive or A is equal to 0. In such a case, then the absolute value of A is just equal to the quantity. Why is that? Because the quantity between the absolute value signs is already positive. All right, so now we want to have a look at the case, what happens if the quantity between the absolute value signs is a negative, right? But we've looked in our previous examples, when I did the absolute value of 3, I got 3. When I did the absolute value of minus 3, I also got 3. Okay, now this minus 3 here is a negative quantity. How come then the outcome, once I took the absolute value of it, I got positive 3 as the answer? Because in the definition, we represent that by a minus A. So let's see how this works. So if you take the absolute value of minus 3, okay? All right, so what does it say? Well, minus 3 is your A in this case, and minus 3 is negative. So the definition says you put a minus, and then you take the quantity being whatever is between the absolute value signs. In this case, it's the minus 3, and we all know that a minus times a minus is a plus. And so the absolute value of minus 3 is equal to positive 3. We've seen this now on both the number line by the representation between minus 3 and 0, and using the definition, the second part of the split definition, where the A, that is the minus 3, is negative. All right, so that is the notation and the examples. So let us have a look then. In your textbook, they use this symbol for the representing distance as an absolute value. So if you've got a number line and you've got your distance between A and B, the distance between A and B is written as DA, B, right? And you can either have it as B minus A, or you can have it as A minus B. So in other words, we have an equation set up here that says that the distance between any 2 points is equal to the absolute value of the difference between A and B. B minus A, the absolute value, is equal to the absolute value of A minus B. Now, in the study guide on page 3, there is an additional exercise, 1.1.1, which asks you to try these examples before moving onto the study guide, onto the diagnostic test, 1.1. The diagnostic test I'd really encourage you to try that because you will then be able to determine for yourselves whether you have understood this concept of absolute values. All right, so now if we look at the first question, the absolute value of x plus 1. Let's try this together. So we have the absolute value of x plus 1. Okay, and we want to simplify this using the absolute value definition. All right, so the absolute value definition says that if the quantity between the absolute values is positive, then we can drop the absolute value signs. If the quantity between the absolute value signs is negative, then we have to put a minus in front of the quantity. Okay, so let us simplify this now. This is the definition, and let's write this in a neater form. So the first part of the definition, let us simplify that inequality. That's for x greater than or equal to minus 1. We will get x plus 1. If x is strictly less than minus 1, then we will get minus x minus 1. So do you notice that when you've got the case where the quantity between the absolute value signs is negative, then all the signs have changed. So the minus in front of the expression using the distributive property changes all the signs. So that is how you proceed with additional exercise 1.1. There are also worked examples like this in your study guide. So of course, you first refer to the worked examples before you attempt the additional exercise. And then I also want to just end off by looking at example 2. So what is given is the absolute value of 3x minus 2. Okay, and now in your study guide, they have asked you to identify why this is incorrect. So on the slide, I've highlighted the incorrect part as being the 0, right? So that is incorrect. That is the part that is incorrect. Can you see why? All right, well, let's have a look at the definition again. It says that depending on whether the quantity is positive or negative, I must apply the definition. All right, so if the quantity is positive, then I'm going to get 3x minus 2 greater than or equal to 0, then I can drop the absolute value signs. In other words, we are happy with that part of the definition, but this is incorrect because it is not when x is greater than or equal to 0. Let us actually solve for x here and see what we get. So we get 3x greater than or equal to 2. Because this is a positive quantity, I can divide both sides by 3, and I can preserve the inequality sign, and I get x greater than or equal to 2/3. So this is the correction for question 2. Similarly, if we look at the second part of the definition, we will get that the absolute value of 3x minus 2, all right, will now be equal to minus the quantity if 3x minus 2 is less than 0. All right, once again, if you solve that, you will get minus 3x plus 2, all right? So we're happy with this part of the definition, minus 3x plus 2, that's correct, that is correct. But what we are disputing is the x less than 0. So how do we correct that error? We solve the inequality and we get x less than 2/3. Please notice that in the definition, of course, if for the positive case x is greater than or equal to 2/3, then for the negative case x has to be less than 2/3 so that we cover all the numbers on the real number line. Right, so good luck. I'd like you to now complete diagnostic test 1.1 and remember that the solutions to all the odd questions can be found in the back of your textbook.